The universe is vast. It's a concept that's difficult to grasp, let alone truly comprehend. The sheer scale of it, the distances involved, and the number of celestial bodies are beyond our everyday experience. But one question always seems to surface. Is the universe infinite? This question has puzzled humanity for centuries, from ancient philosophers to modern scientists. The idea of something extending forever, without end, is a mind-boggling concept. It challenges our understanding of space and time, pushing the boundaries of our imagination. Yet, it's a question that astronomers and physicists grapple with as they explore the origins and nature of our cosmos. They use advanced technology and complex theories to try and unlock the secrets of the universe. The Big Bang Theory, our best model for the universe's beginning, describes a hot, dense state from which the universe expanded and cooled. This expansion continues today, and we can observe it through the cosmic microwave background radiation. But if the universe is expanding, doesn't that mean it must have had a starting point, a boundary? Not necessarily. The expansion of the universe doesn't imply a boundary in the traditional sense. To reconcile the Big Bang with the concept of an infinite universe, we need to adjust our perspective. We must think of the universe not as expanding into something, but rather as space itself stretching. We need to abandon the idea of a central point from which everything expands. Instead, imagine the universe as an infinite, boundless entity, where every point is moving away from every other point. This helps us understand how the universe can be both infinite and expanding. Some theories even suggest the existence of multiple universes or a multiverse where our universe is just one of many. This adds another layer of complexity to our understanding of infinity. The quest to understand the infinite nature of the universe continues, driven by curiosity and the desire to uncover the mysteries of existence. Each discovery brings us one step closer to answering the infinite question. The Big Bang wasn't an explosion space, but rather an expansion space itself. Imagine a balloon with dots drawn on it. As you inflate the balloon, the dots move farther apart. From the perspective of any dot, all other dots seem to be moving away. This is similar to what we observe in our universe. Galaxies are not flying through space away from each other. Instead, the space between them is stretching, carrying the galaxies along for the ride. This expansion happens everywhere, at every point in the universe. There's no single privileged location that marks the center of the Big Bang. If you were to travel to a distant galaxy billions of light years away, you wouldn't find yourself at the edge of the universe. Instead, you would find yourself in a place that looks remarkably similar to our own cosmic neighborhood. You would still observe galaxies moving away from you in all directions, just as we do from Earth. This phenomenon is not unique to our vantage point. It is a universal experience shared by all observers, no matter where they are located in the cosmos. This is because the expansion of the universe is homogeneous and isotropic. Homogeneity means that the universe is uniform in composition and structure on a large scale, while isotropy means it looks the same in every direction. It happens at the same rate in all directions, regardless of your location. This uniform expansion is a cornerstone of modern cosmology, helping us understand the large-scale structure of the universe. This fundamental principle underscores the idea that there's no center to the universe, no single point from which everything originated. The Big Bang was not an explosion in space, but rather an expansion of space itself. We are not at the center of the universe, nor is any other point. Every location in the universe can be considered the center from its own perspective, making the concept of a central point meaningless. Every observer, regardless of location, would observe the same phenomenon of galaxies receding. This is a direct consequence of the universe's isotropic nature, ensuring that the laws of physics are the same everywhere. This is a key concept in understanding the infinite universe model. The idea that the universe has no edge and no center challenges our traditional notions of space and time, inviting us to rethink our place in the cosmos. The infinite universe model suggests that the universe extends endlessly in all directions, filled with countless galaxies, each with its own unique story. To better visualize this, imagine an infinite line with points dotted along it. Now, imagine that the distance between each point increases over time. This is a simplified, one-dimensional analogy for the expanding universe. If you were standing on any point on this line, you would see all other points moving away from you. The farther away a point is, the faster it appears to recede. This doesn't mean you're at the center of the line. it simply reflects the fact that the line itself is stretching. Section 5. Stretching the infinite line. Now let's imagine rewinding this expansion, bringing the points on our infinite line closer together. As we go back in time, the distance between the points decreases. If we continue rewinding to the very beginning, to the moment of the Big Bang, all the points on our infinite line would converge to an infinitely dense state. This doesn't mean the line itself shrinks to a finite length. It simply means that the points on the line become infinitely close together. The line representing our universe remains infinite. Section 6. Rewinding to the Big Bang. Imagine traveling back in time, witnessing the universe in reverse, shrinking and condensing. This concept can be extended to our three-dimensional universe. Picture the vast cosmos with all its galaxies, stars, and planets gradually drawing closer together. As we rewind the expansion of the universe, we approach a state of extreme density and temperature, the Big Bang. This moment marks the beginning of everything we know, but even at this point, the universe could still be infinite in extent. The concept of infinity is mind-boggling, yet crucial to understanding the Big Bang. Think about it this way. If you take an infinite space and compress it, it remains infinite. The scale changes, but the essence of infinity persists. It simply becomes infinitely dense. This density is beyond our everyday experience, a state where the laws of physics as we know them break down. The Big Bang wasn't an explosion into an empty void, but rather the rapid expansion of an already infinite universe. Imagine space itself stretching and growing. The Big Bang model doesn't require the universe to have a finite size at its beginning. Instead, it describes a universe that was once incredibly hot and dense. It simply describes a state of high density and temperature from which the universe began to expand. This expansion set the stage for the formation of galaxies, stars, and eventually, life itself. The journey from the Big Bang to the present day is a story of cosmic evolution, a testament to the dynamic and ever-changing nature of the universe. Section 7. The Infinity Equation. The concept of infinity can be challenging. One way to think about it is through mathematical terms. If you multiply infinity by any non-zero number, the result is still infinity. The universe, even at the moment of the Big Bang, could have been infinite. The rapid expansion that followed simply increased the distances between points in this already infinite expanse. The Big Bang theory doesn't dictate the size of the universe at its beginning. It simply describes the evolution of the universe from a hot, dense state. An infinite universe, even at the moment of the Big Bang, remains entirely consistent with this model. Section 8. A universe without bounds. So, how do we reconcile the Big Bang with an infinite universe? The key is to shift our perspective. The Big Bang wasn't an explosion from a single point into a pre-existing space. It was the rapid expansion of space itself, everywhere and in all directions. This expansion continues today, stretching the very fabric of space-time and carrying galaxies along for the ride. There's no center, no edge, no privileged point of observation. Every observer, regardless of their location, would observe the same phenomenon of galaxies receding. Section 9. Implications for our understanding. The concept of an infinite universe has profound implications for our understanding of the cosmos. It suggests that the universe is far grander and more awe-inspiring than we can possibly imagine. It also raises intriguing questions about the nature of space and time, the distribution of matter and energy, and the possibility of other universes beyond our own. The exploration of these questions continues to drive scientific inquiry, pushing the boundaries of our knowledge and challenging us to expand our understanding of the cosmos and our place within it. Section 10. The Ever-Evolving Cosmos. As we delve deeper into the mysteries of the universe, we must remain open to the possibility that our current understanding is incomplete. The universe is constantly challenging our assumptions, revealing new wonders, and pushing the limits of our imagination. The journey of scientific discovery is an ongoing process. Each new observation, each new theory, brings us closer to a more complete understanding of the cosmos and our place within its grand expanse. Section 11. The Unending Quest for Knowledge. The concept of an infinite universe serves as a reminder of our own infinitesimal place in the grand scheme of things. It humbles us yet also inspires us to continue exploring, to keep asking questions, and to never cease in our pursuit of knowledge. The universe is vast, mysterious, and full of wonder. As we continue our exploration of the cosmos, we can be certain of one thing: the journey of discovery is far from over.